So we're going to try to evaluate the line integral using Green's theorem of the curve C will be named later, but x squared minus y squared dx plus 2xy dy, and C is the curve r equals 1 plus cosine theta. In other words, C is this limaçon described in this little picture here. So of course the curve is like, what if we started here and ended here, would be our line integral through this force field, x squared minus y squared I plus 2xyj. So if we were to do such an evaluation, we would say, well, let's switch over and use Green's theorem, because the double integral ought to be nice and simple to calculate. And the partial of n with respect to x is 2y, and the partial of m with respect to y is negative 2y, and when you subtract 2y minus negative 2y would be 4y, so we want to integrate 4y dA, but certainly with a region like this it would be smart to use polar coordinates, and the limits of integration, if you draw a ray out from the origin, it crosses 1 plus cosine theta, and it comes all the way back to r equals 0. So there's our limits of integration, and our theta 0 all the way to 2 pi. So that should come out pretty nicely. So we want to integrate 4y times r d theta, and of course y is really just r sine theta, so we integrate 4r squared sine theta r dr d, sorry, 4r squared sine theta dr d theta. Got that better that time. So 4r cubed over 3, r going from 0 to 1 plus cosine theta. So it has something like 1 plus cosine theta, that quantity cubed, over 3 times the 4 that's there. So 4/3, 1 plus cosine theta cubed times sine theta. Of course, u equals 1 plus cosine theta, and that would work out nicely. Of course, that would change our limits of integration. U going from, I guess, 0 to 2 or something like that. But I've talked my way through that. I think you could probably, this integration is going to be easy. It's something we learned in another chapter. But if you do that integration from 0 to 2 pi, turns out that you get 0. And interesting to, maybe we could have gone back to the beginning and determined that we had something like a conservative vector field, and if we started and ended at the same place, we should have known we were going to get 0. How about that?